in a way. Yeah. So I hope you did manage to do the tutorial question. Um, any problems, difficulty that you would like to mention? Yeah, Calvin can do all the question, is it?
Yeah.
Farah, Farah can do all the question. So far, okay. Hmm. Not getting any response from Farah.
Hello, hello. Yeah. I just joined.
Okay. Okay. Um,
What was it again?
the tutorial. Did you manage to do it this time?
Um, yeah.
Good,
But
good.
yeah.
Mm.
I just want to know about the question 6 lah.
Oh, okay. Right. Yeah. So there's 5 questions which we're going to discuss today. In a way, we will check whether you get the correct answer. But of course, in the question, the final answer is already provided, so you know whether you got the answer or not based on the final answer provided to all of you. Yeah. So we're going to start with question number 2. Now, this is about a group of students. They're studying levels in school in a certain area, and it's divided based on gender. We have 56% they are boys, and 44% are girls. Yeah. And another information given is that um, 1/5, or rather 20%, are studying chemistry, and it's for the boys, yeah, and that the girls studying chemistry is 1/11. And the question is asking, find the probability that a pupil selected at random from this group is a girl studying chemistry. So in this case, we want to find out the probability of girl and studying chemistry. Yeah, given that this student is studying chemistry. So the first thing you should be doing is basically identifying the information that is given to us. So I've used this legend, M for male students, F for female students, A is studying chemistry. Yeah. So these are the notation I use. You might be using a different one, so it's still okay. So once we have identified that, for this question, I would suggest to draw a probability tree. Yeah. Because what is given to us, 56% are boys and 44% are girls. So this is the first branch that you should have. Yeah. 0.56 correspond to 56% and 0.44 correspond to 44%. And then followed by from the boys, or basically the male, studying chemistry would be 1/5. So that would be 20%, right? 1/5 is 0.2, roughly about 20%. So I've labeled A to indicate that the student is taking chemistry. And when A is 0.2, therefore not A, that means the boys did not study chemistry, is 0.8. Yeah, always remember that one branch must total equal to 1. So same thing here for chemistry for girls is 1/11, and the students who does not study chemistry would be 10/11. So basically this is the probability tree. Yeah. So I hope all of you also attempted this question using the probability tree. But if you have done a different method, it's still okay. Now, the next thing you should be doing is to list out all the joint probabilities. So you can see here, probability of M and A is 0.56 times it's 0.2. So that would give us 0.112. Same thing for MA, not A. Yeah? You get 0.448. F and A, female and studying chemistry, is 0.040 because 0.44 times with 1 over 11. And finally,
0.44 times
oh,
1 over
sorry.
11 is about 0.04.
Sorry about that. That was Siri responding to whatever I say. Anyhow, the last one is F and not A. That means female who does not study chemistry are 0.40. So you just have to multiply them. Yeah. So this is how you should solve it. Yeah, by you know, get the joint probabilities. We call this as the joint probabilities, just like what I've shown in the example during the lecture. So did you all get the same probability tree?
Oh, need to draw the probability tree.
Huh?
I didn't draw the probability tree.
Oh, yeah, if you didn't draw, it's okay because the question actually didn't ask you to do it. But I don't know, how did you derive the answer? By just based on the information, or did you use any other method like Venn diagram? No.
No, I just directly write the formula.
Yeah, that could be also because the first question, let me go to the next slide, is that we want to find a pupil selected at random from this group is a girl studying chemistry. The probability is a girl studying chemistry. So basically what the question is asking is probability of F and A. Oh yeah, it doesn't say given, yeah. So here probability of F and A, I hope by drawing the probability tree here, you'll see how much easier it is to derive the answer. Okay, so we have F and A. F and A is already obtained here, 0.040. And straight away, you get the answer already. Lah. Yeah. Any question about that?
No.
Okay. The next question is, a pupil selected at random from this group is not studying chemistry. So it doesn't say what gender, it just say a pupil selected, but not studying chemistry. So that means you need to focus on the ones that shows not studying chemistry. For instance, this one, and another one is this one. So in order to answer for part B, basically what we want is not studying chemistry because it's not specified of any gender, whether it's a boy or a girl. So it's basically just finding probability of not A, not studying chemistry. And how do we solve this is by looking at the probability tree, we focus on the one that shows not A. So you see we have not A here that ends with not A. That means probability of M and not A. And the other one is probability of F and not A. This is also showing a not A. So in order to answer part B, we're supposed to add these two. Yeah, these two values here. And since already drawn the probability tree, if you have shown it in your answer, you can straight away just quote the answer, which is 0.448 plus with 0.408. Yeah, correct. Yeah, 0.448 and 0.400. And that should give you 0.8480. Any question? So far, okay?
The zero must need to include or
Oh, you mean the last one?
yeah.
Tidak perlu. I mean, if like you don't write it, it's still okay. Yeah.
Oh, okay.
Okay. All right. So I hope it's clear. The next question is a chemistry pupil, chemistry student, selected at random from this group is a male. Yeah. And basically, yeah, we do not actually want to find the chemistry student. We want to find, because if you read the question from the before the starting of ABC, right? Find the probability of a chemistry pupil selected at random from this group is a male. So in this case, what the question is asking is basically probability of male given that the student is a chemistry student. So if you really read the question, it's basically asking for male, provided that he's a chemistry student. So since we want to find out probability of male given that he is a chemistry student, we have to apply the conditional probability. If you remember, the denominator part is M male and studying chemistry, divide by follow the denominator, follow the given, that will become your denominator, meaning probability of A. So this is the formula that I have been, informing you guys during chapter 3. Yeah. So from here, where do we get probability of M and A? It's from here, right? 0.112. And probability of A, of course, we haven't found it yet, but if you look at the probability tree, probability of A is corresponding to the ones that ends with A. So we have one here and another one here. So basically for probability of A, we need to add M and A, which is 0.112, and the value F and A, 0.040. So the probability of A is a bit longer lah. Just like here, but this one is finding probability of not A. Yeah. So for this one, oh yeah, we could also do this part. Yeah, that means you just do the complement method minus with the answer that we already obtained. Yeah. And basically it is 0.112 divided by 0.152. Now, if you see the value 0.152, and if you add the value 0.112 plus with 0.040, it gives the same as 0.152 as well. Yeah, so you just need to divide this and your answer will become 0.7368. Is that okay? Any question? Yeah, that's clear. Yeah. So yeah, some of you did not draw the probability tree. It's okay because this question didn't specifically ask you to do so. Therefore, the marks will be focused on your working lah. Yeah. But I'm interested to know, Calvin, because you didn't draw the probability tree. Did you get the same answer?
Yeah.
Or how did you calculate the not studying chemistry?
It's just 1 minus P probability P times probability. I just 1 minus and then the probability of the intersection A, and then plus minus, and then minus the 0.04 also.
0.04. But how? Oh, I see. From this value.
Yeah, the intersection. I just write P probability. I just write the probability and then multiply for the other probability.
Mhm.
Probability boy, and then probability boy chemistry.
Okay. I wish I could see your work.
It's very messy. I don't think it's very clear. Yeah.
Okay. But you get the same answer, did you?
Yeah.
Okay. But remember, yeah, it is expected for me to see how did you get the answer when you're answering this in the exam. Yeah, I would want to know. So
Yeah,
it
the
must be
three.
clearly shown.
The 3 is better. Yeah.
Yeah, it's much more clearer, isn't it? By using the tree.
Oh, yeah.
Yeah. So if you can try and apply the probability tree to help you to answer. And normally when you want to construct the probability tree, can let me go back to the question. It would be best if you read it like line by line, because the first line, the first sentence would give us the first information about the probability tree. Then the second sentence would give us the information of the second part. And if there is a third part, the third sentence would do that. That is the format of the question as what I observe or as what I review based on the past year exam question that we have in this course. Yeah. So I hope with this exposure, same thing like in the notes, you guys will know that it's best to use probability tree, but it still depends on the question. Some question you can use the Venn diagram to do it best. Some question you can use the contingency table to do it best. So I'm interested to know, yeah, Noel, how did you solve this question? Did you draw a tree, a Venn diagram, or contingency table? How did you solve this?
I used the tree.
Okay, that's good. Did you manage to construct the same probability tree?
Yeah, but I don't have the joint probability.
Or you didn't jot down the join, but you did manage to get the same value, yeah?
Yeah.
Okay, very good. Sarah, did you draw the probability tree?
Yeah.
Okay, that's good. Yeah, so I hope all of you understand the construction of the probability tree. So yeah, if there's no question, I shall move on to the next question. This is question 3. Now this question 3, the question also didn't ask you to draw a probability tree, and basically I also didn't draw the probability tree, so I hope I won't make a mess here. But the question is asking what chance does the firm have of winning the new job? So that's why it's written here, probability of winning the new job. Now checking back on the information, a firm to win a contract of a new job, that the probability on finishing the job early, on time or late are 0.9, 0.7, or 0.1. Yeah. And the management has been told that the chances of finishing the job, early, on time, or late are respectively given as this percentage. Yeah. So what chance does the firm have of winning the new job? So in this case, yeah, let me show you the working is that probability of winning the new job provided early times with probability of early. Yeah, because that means we are given the value of early, on time, or late. So that means, because I didn't draw it here, let me draw it here. We have 3 branches. So it could be early, on time, or late. So these are the value of 0.9, 0.7, or 0.1. And then carry on to, hang on, am I making a mistake in terms of the probability tree?
I don't think given you can do this for given.
Yeah, for given no kan. It can lah. Can. win or not win ba? Like that ba? Kelvin. So this is the joint probability of it because it's given 5% for winning. Did I write it incorrectly?
Because this cannot be used for given.
I was thinking of
Only when intersection cannot.
intersection.
You cannot do
But-
given with 3.
Different events can be done because if you look at this is this is a Bayes theorem kind of formula. So we want to find probability of winning, probability of W. So W means everything that ends with a W. So that means for early would be 0.05 here. Hang on.
You cannot.
And then 0.95 here. And then for on time, it would be 0.2 and 0.8. And then for late, it would be 0.75. Sorry about that handwriting, and this one would be 0.25. Ayo, my handwriting is very bad. Should have transferred to. So if you put the joint, the first one is this probability of winning given it is early times with probability of early, and then on time, and then late. So that means we multiply all this. Yeah, correct lah, the representation.
Or 3 can also use for given.
Yeah, can. So this is just to show you, how it is. I get confused with it sometimes. So just now I got confused. Yeah. So this is how we can derive it. So basically, we just focus on the winning lah, like this one and this one, not the one with the W bar. So only these three lah. It's combining them in order to get the chances, because the question is asking for the winning only this actually, which is the same as this expression.
Miss, my one. Terbalik.
Oh, you mean you put the other one winning first?
Not sure how to explain. Can I present?
Oh yes, of course. Should I close my presentation first? Because in order for you to present, then you need to show, kan? Yeah. But remember this, because if I keep, then it will be permanent, but I will not save it lah. Okay, hang on. So not yet. Wait for a while. Stop. Okay, so waiting for you, Noel.
So my one like this.
Oh, sama lah ba? Oh, you mean the values are different?
Yeah, I mean the second layer is in the first layer.
Yeah, I see that. But the probability values, but if you read the question, let me go back to the question. From your answer, you put 0.9 winning the new job.
The second layer.
It could be your drawing could be correct, but let me think about it again, because I didn't draw it earlier. I didn't spend so much time on it, but to my understanding, that's how it should be. Because based on the, Hang on now. Oops. Let me think first, yeah. But it should happen the early on time and late should happen first, Noel. But then your probability management, chances of finishing job early on time. Ah, I get you. Yes, you are correct. Yeah. That means your probability value is correct. Because my probability value are the other way around, is it?
Yeah. So
Hang on.
which one do you use?
Hang on, wait. 0.09 times 0.05. And then 0. Don't close first, Noel. 0.7 times 0.2. And then 0.1 times with 0.75. 0.1 times. Okay, class. Hang on. 0.1. 0.1 times with. I think my answer is correct lah. Let me double check again. I mean, in terms of the probability tree, I know regardless whether we're following Noel's method or my method, the answer is still correct. That's confirmed. But I just want to read back the question, which one is which first, yeah? Because winning the contract, that is the probability 0.9, 0.7, or 0.1, isn't it? And then chances of winning the current job early, on time, or late, respectively. Because we have the same probability trees, just that the probability values are different, can Noel?
Oh yeah. Because I thought they have to complete the current project first, then
Yeah.
then they can win a new job. That's my understanding lah.
Then they can win lah kan?
Okay.
After that. Yeah, class. I think I would agree with Noel's work lah. But then your J the letter J stand for
Job.
Job. Oh, you didn't put win. That means job win lah, basically the J. Okay. Class, I would accept Noel's diagram. So this diagram that I have is incorrect lah. Yeah. All right. So everyone, Kelvin, is that okay?
Okay.
Farah? Okay, good. So that's settled then. Thank you, Noel, for the discussion. Okay, then we go on to the next question. Let me share my screen now. Okay. Okay. So that's settled for question number 3, I think. So now we go on to question number 6. This time, it's a bag contains 4 red counters and 6 black counters. And one counter is pick at random from a bag and not replace. And then the second counter is then pick. Yeah. Find the probability that the first one, the second counter is red, given that the first counter is also red. So for this question, it doesn't ask you to draw a probability tree as well. Yeah. Probability tree. Yeah. So here, what I've done is I've used R1 to indicate that the I counter chosen is red and B1 is black. Yeah, so R stands for red, B for black. And I've used I because it could be R1 or R2 or B1 or B2. So B1 means counter chosen is black, the first one, and B2 counter chosen is black for the second one. Yeah. So remember that it's not replaced. So we have 4 red counters and 6 black counters, not replaced. That means not repeat. So the first question is, the second counter is red, given that the first counter is already red. So that means first we need to consider the probability of red counter chosen is red. Yeah, the counter chosen is red. That means R1 means it's the first one. And if you look at the question, there are 4 red counters out of 10. Yeah, so 4 out of 10, because 4 plus 6 is 10. Okay, and therefore, in order to choose the red counter, because the question, the second counter is red, given that the first counter is red. So this is what the question is asking actually for part A. So probability of red counter for the second counter is red, given that the first counter also red. So from here, based on what the question is asking, this is how we write it. And to find it, we are the answer is 3/9, because remember it is not replaced. So therefore the answer, the number of reds reduced to become 3, and the total also reduced to become 9. So that's why our answer is 1/3. So far, okay, class?
Okay.
Yeah, so that's it, how to answer. Any question? No. Okay, the second one, the counters are of different colors for part B. So for this, yeah, when the counters are different color, that means we want to pick 2. Yeah, that means it could be the first one red, the second one blue. Sorry, black. Suddenly blue comes in. Or it could be the first one is the black and the second one is the red. So from here, if the first one is red, it's 4/10 and 6/9. Yeah, as you can see here. Or if it's blue, sorry, if it's black, it's 6/10 and the red 4/9. Yeah, because it's reducing. And remember, red for this color, blue the next one, so it doesn't affect how many number of red and blue. It's still 4 and 6, 4 and 6, because we want different counters, different colored counters for 2 times taking the counters from the back. Yeah, so is that clear? Yes.
Yeah.
Yeah, especially Farah, you said this is the question that you find confusing, is it?
Yeah.
Yeah. So,
Do
of,
we have to do we have to write the do we have to write let Ri and then the
oh
actual
no,
counter?
this is just to explain. But of course, I would expect, in a way, how I would expect your own way of writing. How do you present, or how do you initiate, or how do you show that, okay, probability of the first one is red and the second one is black? Like, this is a good way to show it. So I hope,
We have to write the P probability R1 intersection
yeah,
B2, those formula also.
yeah, because of course, because if you just write the answer, how would I know which? Well, I could read from the answer, of course, what do you mean? But the thing is, you should be able to write this to indicate what is the first one and what is the second one. So that's why I think it's important that you guys see the way how this is written lah, in terms of how do we derive the answer. Yeah. So it is expected of you to write lah. But I don't want to stress you guys a lot also. Like, I mean, if I say you must write like this, then that would be a challenge, isn't it, for you guys? But if you can, why not? But if you cannot, I still give marks lah. I look at your answer and then try to think. But hopefully you guys can, since it's open book. I'm sure you guys can. Right? Yes, Kelvin?
Okay.
Okay. All right. So moving on to the next question. No more question from this one?
No.
Okay. So moving on to question number 7. This is about the Army cadet. They are given 3 routes of reaching a certain destination in a field exercise. And what has been calculated, it's stated here already, that using these routes, the cadet will arrive at the destination with the probabilities given 3/8, 2/3, and 2/5 respectively. So the thing is, there are 3 routes, yeah? Or do you pronounce it routes? I usually pronounce it as routes. And if he chooses a route at random and does in fact reach his destination within the given time, calculated that he used route number 1. So here, for this kind of question, it would be best that to draw the probability tree, because remember that these values 3/8, 2/3, and 2/5 are values that has been calculated, that each of them are different routes. This is number 1, number 2, and number 3, and that he has arrived at the destination. So to illustrate to all of you, we say X, Y, Z. X means the first route, second route, third route, and A is arrive on time, within the time. So basically, the Venn diagram, the probability tree should look like this. That means this is route number 1, route number 2, and route number 3. And that means he arrived at the destination would be the A. Not A means he didn't arrive at the destination. So from the question, you are given for the first route 3/8, second route is 2/3, and the third route is 2/5. Whereas this value here, it's not given, but we can actually calculate it. Yes or not? Based on the answer we have here. Yeah, all these are not given in the question, but you can calculate it. That means this would be 5/8, 1/3, and 3/5. But we will not use it because from here, the probability of using route 1 given within time, that means probability of X given A is based on conditional probability is probability of X and A divided by probability of A. And from here, yeah, we can derive the answer. What is probability of X and A? Is just multiply this, you get 3/8 for the numerator. The denominator is probability of A, means focus on the ones that is ending with A, and it so happen all the values that is already given to us, these 3. So just put it into the formula. Yeah, so 3/8 is corresponding to probability of X and A, and probability of A is corresponding to adding all up the 3/8, 2/3, and 2/5. So what is the answer you get?
1/3.
Yeah, so 1/3? No. The answer would be 0.2601. What do you mean 1/3?
I mean, in my okay.
Oh, okay. Did you get the same answer? No. No. You got 1/3. That's
This
not it.
one, this one need the tree also.
Yes, this
Yeah,
one
what-
you definitely need to visualize it. Unless you see this one and you realize it is the probability of the first route and arrive on time. Yeah, I mean arrive within the time. Same thing for the second one is for the second route, arrive on time, and the third route. Well, if you didn't draw the probability tree, it's still okay, but you see, by drawing it, you can visualize it much better. But no marks on the probability tree, of course.
probability 3 gives marks.
Come again?
Probability 3 gives marks.
No marks.
Oh, okay.
Unless the question specifically state that draw a probability tree, then you have to draw the probability tree then. Yeah. Is that clear?
Yeah.
Okay, that's good. I mean, no more question, yeah? So everybody understand how this is done. Okay, we move on to the last question. This is again quite straightforward. Building program, in a building program, the event that all materials will be delivered at the correct time is M. And the event that the building program is completed on time is F. Now, the probability is 0.8. Delivered correct time and also completed on time is F is 0.65. So we want to calculate probability of F and M. That's the first part of the question. The second part of the question is probability of F completed on time is 0.7 if, yeah, find the probability that the building program will be completed on time if all the materials are not delivered at the correct time. Yeah, so in this case, answering the first part, we identify all the important information first. These are the values given to us. So these are the given values, yeah, probability of M and F is 0.65. So in order to calculate probability of F and M, probability of F given M, we apply the conditional probability formula. Okay, and therefore probability of F given M, this is the conditional probability, and we know that what we have is probability of M and F, which is the same as probability of F and M because they are commutative. It's the same even though you change the position of it. So it's still 0.65 divided by 0.8 based on the information that we have. And calculating this, you get 0.8125. So that is quite straightforward, isn't it? But the question is, if the probability of F completed on time is 0.7, we want to find the probability that the building program will be completed on time. So if probability of F is 0.7, that means, yeah, probability of F and M plus probability of F and not M is 0.7. Yeah, based on, if you visualize the probability tree.
Can I draw a Venn diagram?
I didn't consider Venn diagram. Oh, I see. Then your value of F is 0. F only. is not. You have two events, is it?
Yeah, just M and then F, and then intersection is 0.6, and then we can calculate.
Did you get the same answer? I
Yeah.
haven't visualized that though. So this is your F and this is your M. So here is the 0.65 lah.
Uh-huh.
So that means you're saying if the value of F is 0.7, then this would be 0.05.
Uh-huh.
And then this would be 0.15.
Yeah.
But the question is find the probability on time if all the materials. But this question has nothing to do with because
this one
what-
this one for
Mhm.
how do you say?
Conditional probability.
Oh yeah, this one's looking for the P probability of F intersection not M.
Yeah, because the question is asking if this is the case, the question is, you can see, find the probability that the building program will be completed on time. You see, this is the sentence, completed on time is F. And then stated here, if all the materials are not delivered at the correct time. Because M is concerning with delivery. M is concerning with delivery. So that's what the question wants, probability of delivered, completed on time, given that the materials are not delivered on time. So with this, we have to apply the conditional probability formula, which, as you know, just the numerator is just the intersection between the two events, and divide by the probability of not M. So from here, F and not M, you can see here, in order to identify this value, we know this is 0.65, right? So that means this value here, corresponding to that, would be that. Yeah, 0.7 minus with 0.65. Yeah, so that would give you the value, and probability of not M is 1 minus probability of M, which is already given as well. So you just put all the values in, and that would give you 0.25 as your answer. Okay. Any question?
No.
Is it clear? How about you, Farah?
Yeah. Okay.
Okay, Noel?
Okay.
Did you get the same answer?
Oh, yeah.
That's good. Okay. So anything else that you would like to ask concerning with this chapter? Class?
Does every question need the formula first and then do calculation?
Does the
Every answer need to write the formula, like probability of F intersection M, those
or
things?
like this?
Yeah, I need to write those before you put in the
Yeah.
numbers.
Preferably lah.
Okay.
Preferably, because depends on the cases also. Some, especially contingency table, but still, if the contingency table is concerning of finding A or B, I would still want to see the formula. But then, how to say, I normally, if let's say student didn't write the formula, I would look at your value also. Like you can tell that the value that you have written is following the formula. That is provided if your value is correct. But when you write your value, let's say your value is incorrect and you didn't write the formula, it's very hard for me to identify what did you get it wrong. Yeah. I can still do that. I mean, I can still check, but preferably for you to write the formula, especially like, okay, like this formula, conditional probability, write it down. Yeah. But to say it's a force, it's a mass that you must write, no. As long as you're confident, you know the answer is that, I don't think I would be very persistent in that sense. But of course, if the question, you can draw a probability tree to answer it, draw the probability tree. It's much more clearer in that sense. So I hope that answer your question here, Kelvin. My mind is looking at your our Venn diagram here, and I was thinking whether did you get the same value as 0.25?
Oh yeah.
Oh, you did, by using the Venn diagram.
Oh yeah, I just need to find the F intersection, not M only. So
Mm,
0.05, so I just put it in.
I see. Yeah, there is no wrong way to accept your answer. Okay, I mean, whatever method you use, because some students, I realize, the way you think of probability is different. Yeah, some students, they are, by the book. As what I mean is, you really follow the formula, the concept of probability as what I've shown in class. But some students, I realize, they have a different way to approach the question. They think differently. So that I would have to share with you all, that I'm not going to, immediately put a wrong. I would still consider your answer. It's just that, especially for exam, I cannot verify with you what you meant, just in case your answer is not the same, yeah, as the correct answer. So when that happens and you didn't show the working, it would be very difficult. It could be your working is correct, but I did not give you the full mark. Yeah, so that would be risky lah. Yeah, because sometimes I would not be able to read your mind immediately. So that's why it's important, whatever step that is possible, to write it on the answer. It's different from like essay kind of question, like theory subjects. You can write as much as you want to explain. Yeah. So maths, it's just that when it's dealing with math statistics, you have to write it in terms of symbol, not words. So that's a bit of a transition that students has to go through. So that is where some students, they miss a bit of mark. So if you can write your answer as much as possible, and more especially for computing students like you guys, not only for not only for maths you have to deal with, you have theory subjects, and you have the programming subjects, which, again, a different way of writing your answer, isn't it? Because some subjects you have to write the coding, and different way to approach the question. So I hope by sharing with you guys these few tutorials, I hope it gives you an idea how to write your answer. Yeah, especially for your assignment. Okay. Hello.
Okay.
Okay.
Okay, so yeah, because we finish how do you say, probability chapter 3, and we still have time, about half an hour, so it wouldn't be right for me to just end the class like that, just to be on the safe side, as in not wasting the 30 minutes. I would like to give you some bits of tutorial for you to start on doing, and we'll discuss it in the next class. Is that okay?
Okay.
during
Okay.
this 30 minutes. Of course, I will give a few of the question based on what we have learned in the previous class. That is the normal. We did the normal yesterday, but I haven't discussed with you guys the binomial and the Poisson. Correct? Am I correct?
Yeah.
Yeah.
Okay, so yeah, let me open the file first and then we discuss which question for you to start doing for today's tutorial. For next week, it's for the discussion of next week, but at least you know what you need to do. Not like normally during the week, I'll give you on Monday the tutorial, right? So it might be rushing, and we already covered chapter 4, a bit of it. Just checking whether you got question that you can do already. Wait, not much question though. So we're looking at tutorial 6 now. Yeah. So mhm. I think we'll do question 2. They're quite straightforward question. Duration. So 1, 2, 3, 4, 5. Is that fair? Plus
What again? 2, 4.
question 2, 4, 5, 8, and 10.
Oh.
Question 2, 4. Question 2, 4, 5, 8, and 10. Just 5 questions. Try and do it today lah, because by next week on the Monday, when we finish the binomial and the Poisson, I hope we finish that. Then I will, choose another 5 questions from this tutorial. The remainder of it, this question 11 to question 20. So I will choose another 5 from that. So we have more questions to discuss during our tutorial next week. So advisable that you start to do the tutorial now. There's 5 questions for you to do because you still got time, right? Is that okay?
Okay.
All right.
Okay.
So while you're doing the tutorial question, I will still be here, but I will keep myself silent. I'll stay until 2:30. But if you guys do not have any question and you would prefer to do the tutorial on your own, but hopefully you do it, which I believe all of you do, you can go out from the Google Classroom, the Google Meet, and then yeah, I'll still be here if you have any question. If you do not have any question, it is okay. Yeah. Okay, so I let you do the question. You got the question already, Kat?
What's the last question? Is it 11 kah?
No, 11 is already a binomial question. It
Oh,
will
10.
be,
Oh, okay.
yes, number 10. Question 2, question 4, question 5, question 8, and question 10. This is tutorial 6.
Okay, okay.
All right, so carry on doing the tutorial then.